All right. This video is going to be talking about trig functions. And we're going to see how our trig values on the unit circle can create a function. And so let's just talk about what's going on here. We all know the unit circle. Radius of 1. It rotates starting on the x-axis, and it rotates positively around the circle. As we rotate into each quadrant, we come up with different right triangles here based on the coordinates. You know, in quadrant 3, they're both coordinates and negatives because, you know, x is going negative, y is going negative. And that's what goes on here. And we know that the sine or the cosine of this rotation angle here have the same values in each quadrant. The only thing different is some of them are negative, some of them are positive. So if we concentrate strictly on let's concentrate on the opposite here. We know that this is the sine of the angle on the unit circle. The y-coordinate is the sine of 34 degrees here. So if I were to go over here, we could make a triangle, about right there, that is the same size exact triangle. And the sine value is going to be exactly the same. It's even still going to be positive because it's in quadrant 2. I can go here to 180 plus 34. Where's that at? Same size triangle, same y value. The only difference is it's negative. So we know that in each quadrant we come up with a congruent triangle. Of course, we memorized on the unit circle that 30 degrees. That's pi over 6 radians, true. 150 is the one that's close to that one. It's 30 degrees to the x-axis. That's the reference angle. That's why that 150 rotation creates the same sine value as the 30-degree rotation. The triangles are congruent. Okay, so we know this unit circle. He goes around and around. And if you look at this unit circle, the y goes down here in the second quadrant, and then it goes back up again as we rotate. Then it goes back down again. Y is smaller, y is bigger, smaller, y is 0 now, and then it goes to maximum like that. So look at this. I'm going to set this one going here. And now pay attention to that y value as the point rotates around. So here we go. Let's run the animation here. And let's watch him. Y value gets big. He maxes out at here, right? Has a maximum of 1. Gets down to 0. Just watch the length of that red right there. The y value there. The cosine of that angle. Excuse me, the sine of the angle, not the cosine. Watch that sine of the angle there. Y coordinate, smaller, bigger, maxes out, gets smaller again. Maxes out, then gets smaller again. So you can tell that as we rotate around the circle, it's a repetitious pattern here. He's getting negatively bigger, negatively larger. Now the magnitude is smaller, smaller, smaller. Getting positively bigger, maxes out at the 1, and comes back down. This is what I want you to think about when we talk about the function. Now, what do I mean by a function? What do I mean by a trig function? Well, we know that a function is any type of pattern that has an input and it creates an output. Here's the most basic linear function, y equals x. So basically, we want to see what happens when we introduce a trig value onto this x, into the input value, onto the domain value. So when I say trig function, I'm talking about like this. I'm saying if I have an equation here where I put a sine, I'm taking the sine of that input. Okay. Now, the first place you naturally want to look when you do a trig function like this is your graphing calculator. So you take out your calculator, and I'm going to hit on here, and I'm going to hit y equals, and there's our function entrance, just where you input your functions, and I'm going to hit sine of x. All right. So I hit the graph there, and what you get is a funny looking thing here, a funny looking graph. I'm going to zoom in a little bit and make the window, let's make the y minimum like -2 and the y maximum 2, and you'll see it more pronounced. A sine function has a funny looking wave graph. And I want you to look at this graph as we move along here. What is the sine value doing? It's getting larger, then it gets smaller again, then it gets down to -1, then it gets to 0. Does this look familiar? Remember that circle rotating around and the length of that y coordinate on there, on that unit circle? Check it again. If I were to set this guy in motion, there it is. So what is happening here in essence is, for a function, we're laying out the rotation here around is the x-axis. Let me show you what I mean. What I mean is this. You know, as we move around the circle, on the unit circle, the length of that arc is the number of radians, right? And we know that there are 2 pi radians in one full rotation, right? And there's 1 pi and a half rotation. So look at, I'm taking that arc length there, and I'm turning it into the x-axis, into the input. So the radians, or the rotation here, is the x-axis on the function now, see? So I'm taking that arc length and laying it out as the x-axis for my function, for my y equals sine of x. All right? There it is, about 3.14. That's 1 pi worth of radians around half a circle. Now if I go to full rotation, I end up around 6.2, right? Oh, right there. There I am, about right there. So 1 full rotation. Now I'm going to introduce a graph of this y coordinate, of this sine value of that radian rotation, of that rotation. Watch what happens here, ready? I'm going to flatten this sine out. Instead of going around in the circle, I'm going to create a function where it goes along. You'll see. Watch this. All right, there's the sine function. It's a red dot. Keep an eye on that red dot there as I rotate around. So the red dot is corresponding with the rotation along the x-axis here. See there, now the red dot, he's going to maximize right there. Then he's going to go down again. He's at 0. Now we're going into the third quadrant here. The sine value is negative, so he's in negative territory here. And then finally, he's going to come back to 0 again. And the pattern repeats as you rotate and rotate. Now I'm going to set this into animation, and then I'm going to set something else. Watch this. So watch that sine function. I turn the trace on. Now watch this. As I rotate around, there it is. There's a quarter rotation, half a pi, radians. He maxes out there. Half a rotation's pi radians. He's back at 0 again. 3/4 rotation. It's down there. And then finally, we're reaching at 360 degrees, or 2 pi radians. And where are we at? Back at 0 again. So there it is. This is what is known as a sine wave. That is a type of function. And that is the sine function right there. Remember, what was the sine of 30 degrees? What was the sine of pi over 6? Let's go to 30 degrees here. Guess what it was? It was 1/2. There it is, see? It's exactly 1/2 after pi over 6 input. Right. What was it at 60 degrees? Remember that? 60 degrees was, the value was square root of 3/2. There he is. He's almost there. The sine at 90 degrees, or pi over 2, was 1. There it is. So this is where the sine function comes from. It comes from the length of that y-coordinate as you rotate around the unit circle. Notice how it does. The positive sine function starts in the middle, and he works his way up, goes to the top, works his way down, and then he ends up in the middle again. That is the basic pattern for a sine function. Now I'm going to show you the cosine function. All right. Remember, the cosine function was the x-coordinate, how far sideways as you rotate. And look at that. He starts out at 0. He's at 1. So immediately he's getting shorter, right? So as I rotate around here, here he goes. He's getting shorter and shorter. Look at 90 degrees here, or pi over 2 radians. The cosine function is not left or right. He's at 0 there. So he starts out at 1, and then he goes to 0. And then he goes to -1 over here after pi rotations, or 180 degrees. And then he gets shorter again, longer. So his is also repetitious, but in a different direction here, in a different manner. Now I'm going to turn on the function. Let's look at the graphing calculator first real quick, see how he looks. So remember, sine was starting in the middle, right? Let's change that to cosine, see what happens. Graph it. Concentrate on here. Here's the starting point. He starts at 1. That's his value at 1. Then he goes down and back up again. Let's turn it on the GeoGebra here. Sure enough, remember, the x-axis in the function here represents our rotation around, or the arc length around the circle. So there it is. Let me turn on the arc length here so you get it. So there it is. As the arc length goes along the x-axis, the cosine function follows along. He goes to 0 at 90 degrees. 180, he's at -1. Also known as pi, or 1 pi rotation. Then at 2 pi rotations, he's approaching, he gets back up to 1 again. There it is. There he goes. I'm going to turn the trace on and turn the animation so you can watch it. All right, here we go. Animation on. Here he goes. As we rotate, watch that cosine function. There he goes. That is where these trig functions come from. They come from the repetitious nature of each of the coordinates around the unit circle. Look at that. Look at that. You see it right there. There it gets back to 1 again. Watch that for a minute. It's a beautiful thing. This is a cosine curve. Cosine curve starts at the maximum. He starts at 1, heads downward, the bottom, back up again. That is a trigonometric function right there. And we'll discuss how we can apply this to real life and everything on the next lesson.